Lesson number 5, we're going to talk about combinations and what happens when we have the terms at least and at most embedded within the problem. Alright, so let's look at class example number 1 here. The student council decides to form a subcommittee of 5 council members. And they want to look at how funds can raised should be spent on the students of the school. And there are a total of 11 student council members. We have 5 males and 6 females. How many different ways can the subcommittee consist of exactly 3 females? So if I have exactly 3 females, then there would be 3 females and there would be 2 males, because we have to have 5 council members, right? So 5 is the maximum amount of people that we want. So if there's exactly 3 females, then there has to be 2 males. And so the combination would look like this. Since we have 6 females to choose from, but we're only choosing 3 of them, and out of the males we have 5 males to choose from, but we only have 2, we're going to look at looking at 20 times 10, or 200 different ways. Now if I want to have at least 3 females, so at the very least there's 3 females, so I could have 3 females and 2 males. I could have 4 females and 1 male, or I could have 5 females, right? These are the different ways that I can organize what I have. Now, if I have 3 females and 2 males, I already know that that's going to be 200. That's what we did in the first problem. But I could also have 4 females and 1 male, and if that's the case, it's going to look like this: 6C4 times 5C1. Remember that 1 has to do with the 1 male. And then 5 females, remember there's a total of 6C5, so I'm going to be left with 200 plus, let me grab my calculator here, 200 plus 15 times 5 plus 6. And that would give me 281. Now, here's where we have, now we're dealing with at least here, and we're dealing with at least here as well. So if I have at least 1 female, then I could have 1 female, I could have 2 females, or I could have 3 females, right? And at least 3 females. So what I'm going to do here is, instead of going like 1 female and 4 males, 2 females and 3 males, remember that I already calculated at least 3 males, which included 3, 4, and 5. And so I'm just going to include this number. I'm going to say plus 281, because I already calculated at least 3 females. Now, it's not like it shortened the question because we already did that much work, but I don't have to do that much work again, right? Because I'm just going to assume that I can include it into this new calculation, which is going to be 1 female and 4 males, which is going to be 6C1 and 5C4 plus 6C2 and 5C3, then plus 281. So that's going to be 6 times 5 plus 15 times 10 plus 281. So we get 30 plus 150 plus 281. So 180 plus 281 is going to be 461. Alright, so that's one way we can do it. There's also another way we can do it, and that's if I subtract the number of no restrictions. So number of no restrictions. Now, what we were doing here is we were talking about how many restrictions we had in terms of male and female. So if I talk about no restrictions, that would be if I have 11 students and I can only choose 5 of them, and then I subtract the number where there's no females. Right? What that leaves me with, and so there's only one way where we can have no females out of all of these different combinations, and that's if I have 5 males. And so what this is going to become is 462, and there's only one way to have all males, so that's one way. There's 461 ways. The reason I would do it like this, the number of no restrictions minus the number of no females, is because every time I wanted at least one female, right? And so if there's one way where there's no females, I subtract that from the number where there's the total number of students, or no restrictions, then I end up getting at least one female in 461 ways. Now let's look at example number 2. Consider a standard deck of 52 cards. How many different 5-card hands can be formed containing at least one card? All right, so let's do it like we did over here. So at least one red card. So let's think about the number of no restrictions, and we'll subtract the number of no red cards. And it's just like we did earlier in this first example. And so how many ways is there, or how many different 5-card hands can be formed by a 52-card deck? Well, there's 52 cards in a deck, and I want to pick 5 out of those 52. And out of the black cards, there are 26, and I could choose 5 out of those as well. And so if we calculate this, 60, we're going to end up with 2,509, or 98960. So 2,598,960 minus 65,780, and we get 2,533,180. Now, how many ways can I have at most 2 kings? So I want to have at most 2 kings if I draw 5 cards.